Hey everyone, welcome back. We are going over the Chemistry 1 topic of compound percent composition, and specifically we are going to do some difficult practice problems. And I classify these as difficult because they require you to do two things. It's not just finding the compound percent composition, they ask you to go an extra mile. And you guys will see I have two examples in this video. So the first one, we have C9H10O. That is a molecule that we are going to be covering in this problem. And for time's sake, I put the molar mass. If you want to know how to find the molar mass of a molecule, I have a link below of the video that I posted on that topic. So part A of this question wants us to find each element's percent composition, and then part B wants us to find how many molecules of C9H10O are in a sample mass of 0.49 grams of it. So the first one we have actually gone over, so it shouldn't take us too much time. We just have to delineate every element in the molecule and plug in all the information required in the formula. So we're going to start with carbon. There's 9 molecules. There are 9 atoms of carbon in this molecule. 12.01 grams is carbon's molar mass, and then the molar mass of the element is 134.17 grams. Multiply that by 100. And we are going to get 80.562%. Alrighty, same process for hydrogen. There are 10 atoms of hydrogen in the molecule times 1.008 grams all over 134.17 grams times 100 is equal to 7.513%. For oxygen, you can follow the same process, but for time's sake, I want to show you guys how we can add these two and then subtract whatever that result is from 100. So 7.513 plus 80.562. Let me do that again. 7.513 plus 80.562 is 88.075%. So subtract that from 100. I know that oxygen has to make up 11.925%. Now, if you do the math, you'll come up with that as well. For time's sake, I'm not. As you're going over this particular topic in this part of your chemistry course, this is an example of where you can save time on your exams and your quizzes. All right, so part B is asking us how many molecules of the compound are in a sample mass of this amount, which is 0.469 grams. This is something that we are going to have to do dimensional analysis with. If you guys recall in my video, dimensional analysis is a process where we start with a known number to find the unknown number that we're looking for. So the known number that we have that I'm going to start with is this part right here. So I'm going to start my dimensional analysis with 0.469 grams of the molecule. So whatever unit I have at the top, I'm going to put at the bottom. So grams of C9H10O This is a 9. Okay. Do I have a direct conversion between molecules and grams? No. But I can go from grams to mole and then moles to molecules, because moles to molecules involves Avogadro's number. So I can go from grams to mole. So I'm going to put mole at the top of C9H10O. Okay, so 1 mole of the molecule is equal to the molar mass of the molecule, which is what we have up here. So I'm going to put that in there, 134.17. Now I can cross out grams and know that I'm going to end up with mole of C9H10O at the bottom. Now, do I have a direct conversion factor that will give me mole to molecules? Yes, I have the Avogadro number conversion factor, which tells me that 1 mole of anything contains 6.022 times 10 to the 23rd. Since we're dealing with the molecule, this case it will be molecules. 1 mole of this molecule brings 6.022 times 10 to the 23rd molecules of that molecule. So then we're going to do the math. Now I can cross out mole and mole, and whatever my answer is going to be in molecules, which is what they're asking, how many molecules. So I already know that the answer is going to be in molecules. I just have to do the math now. So I'm going to multiply everything at the top. So that's 0.469 times 1 times Avogadro's number. And I'm going to divide it by everything at the bottom, which is 134.17 times 1. Once I do that in the calculator, one moment. My answer is 2.105 times 10 to the 20 molecules. Alrighty. Next one is, how many moles of iron are in 24.6 grams of the molecule? Now, for time purposes, I'm just going to write down what the molar mass is, and that is 159.86 grams. Now, we need to find moles of iron, which is the element in the actual. We need to find moles of iron element in the actual molecules. In order to do that, I need to find the percent composition of iron first. So we know how to do that. We use that formula that we know we have to use. So iron has 2 atoms in this molecule. So 2 times the molar mass, which is 55.93 grams, over the molar mass of that whole molecule times 100 is equal to, calculator is 69.974%. So that's the percent composition, but they want to know how many moles of iron are in this particular quantity that we have. Since we know that it is 69, almost 70% iron, we know that of this 24.6 grams, almost 70% of it is iron. So what's 70% of 24.6? We're going to find that out. So 24.6 grams times 0.69974 is equal to 17.214 grams of iron that was in the larger molecule. I hope y'all can connect. That's really quick. Let me fix that. 69.97% is the same thing as 0.69974. I just moved the decimal point 2 points to the left. Okay, so now, but we still have to find out how many moles. If we have grams, we can get to moles. So we're going to do 17.214 grams of iron. Whatever we start at the bottom, at the top, we put at the bottom. And we know that there's a direct conversion factor from mole to gram. What's the molar mass of iron? We look at the periodic table. It's 55.93 grams. Now I can cancel this out. Whatever my answer is going to be in moles of iron. And then I just do the math. Everything over on the top divided by everything on the bottom. 17.214 divided by 55.93 gives me 0.308 mole of iron. If you guys have any questions, let me know in the comments, and I will see y'all next week.